Hello, everyone, and welcome to another episode of Into the Terminal. I'm your host, Scott McBrien, and I'm joined, as always, by Repo Manager Nate.
Repo Manager Nate. You might guess that today we're going to talk about software repositories. I mean, it's in the title and it's in my name. So.
Yeah, so you'll remember our last episode, we talked about building our own RPMs. And in fact, we're going to see one of those come back today um, because today we're going to be working on building our own software repositories that have those custom RPMs. So, Nate, how will we jump into the terminal?
Jump right on in. All right. So I have a quick demo here of basically setting up a local repository. We're going to do this as the RHEL user because you don't have to do this as root. And you may argue for the sake of, security that maybe you don't want to do these things as root. So I have this little RHEL user set up like we do on so many of our labs. First thing we're going to do is we're going to make a place to put our repository. So just a sec here to copy out my commands. And then we're going to go into that repo. Because I'm so vain, it's called Nate's repo. And then for the initial setup, we're just going to download some RPMs from your standard RHEL repositories, right? This is just because we need some fodder to show you how this works. Obviously, normally you wouldn't just grab stuff from RHEL because you can just get it from RHEL, right? Normally you'd put your own RPMs in here or RPMs you've gotten elsewhere that you want to make available to your organization. There are reasons you may repackage the RHEL stuff, like if you're doing an offline setup, like a disconnected environment, but we're not really going to go into that quite so much today. Okay, so now we have just a bunch of RPMs in a directory. That isn't quite a repository. I mean, at its strictest sense, I guess it is, but it's not a useful repository. There's a tool called createrepo that will actually turn this into a DNF or Yum repository. Create repo, and then you give it a path, just the local directory. And all this really does is it takes an index of what's in here, and it builds us the repository metadata. You'll see now there's this new subfolder called repo data. And inside of there's some compressed archives of like SQLite databases and some XML, and then the repo MD, which basically tells your package manager what's in this repo and where to find these files and whatnot. All right, so now we have a repository. Let's use it for something, right? So we're going to just, first of all, we're going to exit out of our RHEL user because now we're going to do this as root because you can't set up a repository as a standard user.
And Nate, for the clear the screen and operate
the
screen, please.
Sure thing. There we go. Now I'm going to disable the RHEL repositories just for the sake of clarity. Right. This is so that you can see what I'm doing. Normally you wouldn't disable these, but because I'm using packages that come from RHEL, I don't want confusion when we start looking at packages afterward. Also, there's no man behind the glass here, right? It's this is for reals. We're gonna install some packages from the repo that I just created. So now if I do a DNF repo list, there should be no repositories enabled, right? Now we're going to make a repository definition inside of our local system here. Now there's a file in etc yum.repos.d. This is just, I guess, from the old days when it was still yum. I guess we didn't change it for compatibility reasons. We're just going to make a new text file called Nate's repo, nates.repo. And we're just going to paste in the definition for a local file repository. Okay, now this is not remote. You could theoretically do this over like NFS and still use the same file : / and then path to where the repository is. But in this case, for the sake of the demo, we're just going to point it to literally the home directory for RHEL, that user that I made and where I put the repository. Give it a name. We're going to say that it's enabled, and we have GPG checking turned off. That's intentional for now. We'll talk about that later.
And so it's important to note, I think, that using a locally stored file-based repo is probably not what we would see out in the world. Out in the world, we would use something like HTTPD or FTP provided repos. We're doing that for the sake of like just getting the example done for the critical path.
This is also a great way to test whether your repo works. The system where you built your repo and where you made the metadata and whatnot, this is a great way to just test it and see, like, does the basic repo work? There's no other complexity in the way there, right? Oh, is Apache serving it properly? Are the permissions right? All that's out of the way. Just does the repo work? This is a good way to test that. All right, so now we're going to clean out our DNF cache just because it probably has a bunch of cache from when it still had the Red Hat repositories added. And then we're going to do another repo list. And it should show us the repo we just added, Nate's repo. Nate's super awesome repo. Okay, now, obviously I put some packages in there. I didn't show you exactly what packages were there. We did do an ls, but I didn't cover it that closely. But I'm telling you that I added Nginx to it. So we're going to search for Nginx. And what it'll do is it'll from our repo data right there. There's Nginx, right? Now, this is all from my local repo. Now, you'll notice there's some dependencies. I also pulled those in when I pulled those packages, right? Now, if we do a DNF info on Nginx, we're going to get back the information from the RPM, right? Now, this is all standard stuff, but I do this to show you that we're going to actually look at the RPM in our repository. Let me just copy the path out so I don't have to type it here. Remember, it was in home RHEL Nate's repo, right? You can see that the information from the RPM is the same information that's available in the repo. Sorry, I scrolled back too far there. So this is what came out of the repo. And this down here is what came out of the RPM itself. So we have a successfully working repo. At this point, I can install Nginx on this machine if I really wanted to. So let's go ahead and do that. Okay, there it is. It shows us our dependencies, and if I hit yes, boom, it'll install Nginx. All right, so there we go. Completely functional repository. After the break, we're going to talk about how to make this thing accessible remotely. We have a client system to do this on, and we're going to talk a little bit more about other things you can do with RPM repositories. So we'll catch you in a second.
Stay with us after the transition for more on repository management. And we're also going to cover GPG signatures after.
Yep.
See you in a second. Hey, Nate.
Welcome back. I feel like I just saw you.
So before we jump into like some additional things for repo management, maybe we could talk a little bit about the choices that we made in our critical path example.
Sure.
For example, you mentioned that you were pulling down packages from RHEL into your custom repo, and that you didn't want to do that normally because you could just get the packages from RHEL. So
Right.
kind of things do we often see put in an additional repo like this that somebody's maintaining and creating?
Sorry, I was looking at the chat. So yeah, so obviously the repos, normally what you would do, so there's two reasons you'd run a repo. One is if you're in an environment that's not accessible to the world, or can't reach the world, I should say. Doesn't have to be internally accessible, right? So you'd have an offline repo. Now there's other ways to manage that. You could use satellite, for example, on your local network, and your system could reach just that. I have seen some like hyper disconnected environments where they literally have clones of the software accessible to the local machine because they don't want that machine to touch anything other than itself, right? That's again an extreme example, but completely air gapped systems, sometimes you'll need that. So that DNF download will allow you to download packages. It's probably not the most efficient way to clone a repository. There's other tools to clone repositories with.
So I was thinking more along the lines of people's additional or supplemental software. So like where I commonly see people use their own custom repos is, for example, Adobe. Adobe maintains a repo of software for RHEL, and it is meant to be in addition to what's provided by RHEL, right? So If somebody had software that they wanted within their organization to use, they could collect it from places like Adobe or building their own thing. And then they can put it into this repository definition so that there's their curated internal software that they want to offer.
Yeah, when I worked at the college, we had we had some security tools that were not automatically packaged as RPMs that were compatible with RHEL. So we used to repackage and sign those so that we could install them easily. In our case, it was with satellite, but you could have easily done it with DNF as well, right? But that was so that we could make them easily installable on our local machines, right? And you can easily do that with the examples we used from last week's episode, right, where we talked about packaging RPMs. You can take source, build RPMs, and put them into your own repo, which is a really good use for this.
All right, and also before we switch our to the second half of the show, I mentioned that a local file repo is probably not what we would most often see, especially when you're like curating software for your organization, because that means that you would, I think you had mentioned NFS or some other file sharing software.
Yeah, right.
And that instead we usually see things like a website or a web accessible repository.
Yeah,
Do
most commonly
you want to take,
you'd use it over web. Yeah.
do you
Sorry,
want
we
to take
talked over each other. Yeah, so that's actually our next step here, right? Is we're going to show you how to take exactly what we just built in the critical path, and we're going to make it accessible via the web. Now, I've already installed Apache's HTTPD on this machine, so all we really have to do is take that repository and move it to the proper place. I think I've got that right here in my commands. Right, so we're going to move home rel repo nates repo to var dub html. Cannot stat. What did I do wrong here? Home rel repo is repos with an S, I think. See, copy paste fail. There it is. All right, now if we go to var dub html, you might remember from our SE Linux examples in the past that now I'm going to have to relabel. Right, so that Apache can actually read these files. Otherwise, it's going to give us some errors. Now, this should give us the repository accessible via the web. Let's do a check Apache quick to make sure it's up. Good. I thought I had it up and running already, so that's good to know. All right, now we're going to hop over to a client machine, which is in the same lab here, right? They can reach each other locally. So there's client one. Now we're going to set up a very similar repository on this machine. Oh. So exact same file. You're going to notice that the syntax is very, very similar. Just going to paste this right in here. Once again, we give it a name. This time the base URL, instead of file : / and then the path, it goes HTTP RHEL, which is a DNS name that's locally accessible within the lab here, points to the RHEL server, and then /nates repo, which if you remember, that's exactly where I placed just the repo files that we put in there. It's enabled, and still we have GPG checks turned off. So now we're going to just save this out. We're going to do a DNF clean all. Again, this is just good practice. You may not even have to do this. DNF will periodically rebuild its cache depending on how you have your system configured. When you make a change and you want to see it immediately, it's just good to make sure you clean out that repo cache so that there's no confusion. Now, if we do a repo list, you're going to see Nate's repo right there. Now, you notice I didn't turn off the RHEL repos, and I did that on purpose. We're going to do DNF info on Nginx again and show you how this looks when you have two repos that have the same file in them, right? So now we should see two results in info. One of them will be Nginx that's available from RHEL, and the other should be Nginx, which is identical, but still in a different repo available from my repo. So right here we see Nginx, And right here it says repository RHEL 9 for x86 app streams. That's, of course, the RHEL repo. But right above it, we see Nginx. Same RPM, right? That's a source RPM, but you know what I mean. And oops, didn't want to click on that. Then we see right here, repository, Nate's repo. So now you can see we've got it accessible remotely. If I were to make changes to that repository, which we're going to actually cover in our next example here, then this will be accessible on any machine that can reach this repo or is configured to reach this repo.
So are we going to install the software?
We could install it from here. Sure.
Or do we want to wait until we add our extra RPM that is only available from there?
Yeah, let's do that. Let's do that because I've already showed you how to install Nginx. So let's go right into the next thing. So you might remember from our last show, Scott built a super great RPM called Bellow, right? Well, I happen to have that on this machine as well. Let's go into my repo here. So you can see this is the web accessible tree from my RHEL server, right? The place I'm hosting the repository. We're going to just copy home RHEL repo, no, RPM build. Bellow. We got good old Bellow. We're going to put it right here inside of my repository. Now, we should be able to just go right over here and find it, right? Oh, hold on.
I don't think so.
You don't think so? But I put it there, right? In fact, we won't find it, right? Now, you might remember from the beginning, we had that command where we created a repository, right? When you make changes to the repo, you have to rerun that. And this will basically just recreate the repository metadata, right? So there it is.
The core problem, right? You didn't have this new file reflected in all of the repository metadata. So when you use tools like DNF, it looks at the metadata and doesn't see anything new or changed. So it didn't recache anything. It didn't re-download anything. And because the metadata doesn't reflect Bellow, it doesn't see it in the repository yet.
So now that we did that, let's just try to search for Bellow without doing the refresh. I'm kind of curious at this point. No, still doesn't have it. So we're going to clean out our metadata locally. Then we're going to search for Bellow again. So keep this stuff in mind, right? I'm showing you this for a reason, right? The number of times I've made changes to a repo, and then I go to my clients and I say, where's the file, right? It's because DNF does its due diligence to cut down on network traffic by caching all that stuff locally, so that every time you do a search, it's looking at its local cache instead of trying to look at the remote repositories every single time. Where it's one machine talking to another, that's not a big deal. If you've got thousands of machines talking to your repositories, that makes a big difference, right? And this stuff's configurable, how often it's supposed to update its cache and whatnot. And there you go. Now we have Bellow. Now, again, I don't want to install it yet because I have another example, but I want to stop to make sure, see if we have any questions before I move into the GPG part of this.
So no questions that I don't think have been answered. However, I would like to remind our audience that now is the time to ask questions, and we will handle them on the air. Also, don't forget to mash that like. And if you want to send this to your friend, use sharing. And if you want to get notified when we are doing more into the terminal, don't forget to subscribe to the Red Hat Enterprise Linux channel.
Yeah, because if you don't subscribe, how do you know when we're live, right? I mean, we'll probably tell you. Eric's good about the social stuff, right? All right. So GPG signatures for RPMs, in my opinion, is a pretty important piece, right? So even if you're running your own repository, I still think it's important because it's a good practice to be used to, right? If an RPM is signed, that means that the person who packaged it has cryptographically signed it to say, I packaged this, this is where it came from, right? So all Red Hat RPMs are signed by a key that's included with RHEL, that's included in your RHEL repositories. So any package you download from a RHEL repository, you can check the signature, and DNF will automatically check the signature when it's downloaded to make sure that In fact, it came from where it said it came from. So if you're subscribed to a repository and someone has injected a package in there that was not signed, and your system tries to install it, it'll say, this fails the GPG signature check. You may want to look into this, right? This probably or maybe didn't come from the place you think it came from. And this is just another step, right? It's a lot. It's not trivial for someone to inject a package into a repository. It's a lot less trivial for them to also be able to sign it with the key that that packager has, right? Now, obviously, there's always cases where these things can happen, but it's just one more step, one more thing to check. All right, so I've talked a lot about this. We're going to show you how to sign a package. So first thing, I've already made a GPG key. We have documentation on how to do this on the customer portal, and there'll be a link for that in the notes. I already have it in our internal notes. I'll make sure that it ends up in the notes of the show. So I've already made the key. The key is in root's home directory in the usual GNUPG directory, right? This is just standard. I use GPG to make a private key. I then exported that private key or the public key to this file right here. Nope. Cat can't type today. Right. So this is just like a usual ASCII armored GPG public key. Anyone who's familiar with GPG should be familiar with all the things I've talked about up to this point, right? Now, the procedure for actually building an RPM, sorry, not building an RPM, signing an RPM is we need to tell, similar to the macros we set up when we built RPMs in our last episode, there's macros we need to set up for GPG signatures as well. First thing I'm going to do is I'm going to show you how we import that public key into RPM, right? Now, I'm going to show you how you don't have to do this on your clients, but on the machine that I'm doing the signatures on, I like to do this so that I can then test the signature once it's done. So we're going to just paste this in here. It's just simple. RPM import. I think there's a copy paste problem here with my double dashes. Thank you, Google Docs. This is just pointing to that ASCII armored text file, right? And now RPM stores that in a database similar to how it does your package metadata. And we can query it to find out what keys are installed, right? So here's the command to do that. Again, this stuff should end up in the notes if you want to copy it. It's also in the document that I referenced. And this tells us all the keys that DNF on this machine knows about, or RPM on this machine knows about. Okay, so in here we should see Nate. Here we go. There's my key that I just imported. Now these other ones here, they're from Red Hat. They're from Google because this is a Google Cloud machine, right? But they're all the ones that RPM knows about. All right, now on to the good stuff. We're going to actually try to sign bellow. Now to do that, like I said, first we need to put some stuff into RPM macros, right? And if you remember from the last one, this is where we define the macros that RPM and RPM build use. We're just going to paste in here. So we tell it what kind of signature it's going to use. It's GPG. We tell it where the path for my GPG stuff lives. It's in root GNUPG. Again, you don't have to do this as root. I am just for this example. This tells it which key to use, believe it or not. That's based on the text of the name of the key, right? There's a couple ways to identify it, but I use this because it's the name on the key. This tells it what binary to use, and this is actually the command that it's going to run when it does the signature, right? So again, if you're familiar with GPG, this stuff shouldn't look all that crazy. You can modify that if you know what you're doing. I'm not going to change it because this is the one that worked for me during the demo, or during the tests, I should say. All right, now it should be as simple as signing the key. So let's go back to var HTML Nate's repo. You'll see bellow is in the list here along with all the other stuff that I have, right? Bellow at the top. We're just going to use RPM -- add sign on bellow. Okay. And this will basically use those macros we defined to run the commands and whatnot that we told it to run to sign an RPM. Now cross your fingers. Okay, now passphrase, of course. This is what makes it difficult for other people to sign as you, because you should have a strong password. I chose a really not strong password, but you don't have to know that.
So, Nate, one quick question. So you went through and you created all the RPM macros that outlined your signature details and what command to use and all the stuff. So does that mean that when you compile packages now, it automatically goes in there?
I think there's a flag you can pass to RPM build that'll do that. I didn't test that, but that was a question I had in the back of my head as well. But I was focusing on getting the demo ready for today. Did you have the answer, Scott? Was I right?
The answer is yes.
All right. All right. And then, of course, like I said, we imported that key to RPM so that we could make sure that when we applied that, that it then checks out. And this is a good step because if you just say, oh, cool, that sure looks like it worked, we're done, right? But then the signature didn't apply properly. When you put it into your repo, now people that try to install it are going to get GPG errors. So RPM dash dash check sig, and there's a couple other ways. There's also RPM dash capital K, I think it is. We'll do the same thing to check the signature of an RPM. And there we go. It says digest signatures okay, right? So that means the signature is now applied. Now, what does that mean for our client?
I
Right?
think if you throw on a dash V or maybe a couple dash Vs, it'll show you even more information
There is
on.
a verbose. Right. Dash, is it lowercase v? There we go. Tells us what signatures have headers and signatures and whatnot that are applied there.
Yeah, and another dash V, it'll actually like tell you the RPM GPG key that was used for that RPM signature or that GPG signature, if I remember correctly.
Look at that. All kinds of stuff. So this is great. I actually ran into this while I was making the demo. I was running into a GPG problem where it was not applying the signature properly, and that dash V flag helped me troubleshoot what the problem was. Right. So this is valid info that Scott's given you here. Okay, so we've got the package signed. Now we can tell our client that it has to check GPG signatures when things are applied, right? So give me just a moment here. I want to find the right item in here. Okay. So, actually, let's we're going to try to install Bello without. Actually, no, let's not do that yet. I think I have my instructions out of order here. Oh, this is what I wanted to do. Sorry, I'm getting ahead of myself. I wanted to show you that we're getting a checksum error. Scott, why do you think we're getting a checksum error? We didn't tell this to check GPGs yet.
Well, but applying the signature changed the package checksum, which
There you
doesn't
go.
have metadata that's being
Yep.
used in your cache.
Yep. So we have to do create repo again inside of our repository. And what this does is it'll redo those hashes. It'll put them into the metadata. And then if we did a clean all and tried to install again, it should install it without checking the signature at this point because we didn't tell the repository that it has to check the signature. So we're going to do that next because I don't want to just install it without checking. I want to show you guys that the signature actually works. Okay, so we're going to set GPG check to 1 now. And that tells Yum or DNF, yes, you have to check the GPG signatures when you download things. However, it doesn't know where the key is, right? There's two ways we can deal with that. One is we can take that ASCII armor to text GPG key, the public key, and import it into RPM, and that'll do the job. However, when you're doing this at scale, it's a whole lot easier if you can just tell yum/DNF where to get the key from. And there's surprisingly a command or a config option that you can put right in here. Okay, so I didn't put the file in place though, did I? Didn't. Okay, so now the file's actually in place. Otherwise, this wouldn't have worked. So basically, what I've done is on the same server that's running the repository, I took the GPG key and I put it inside of the root. So now I can tell DNF, go look at RHEL, go get the RPM GPG key Nate L, which is the file that I just threw there, right? Is that what I named it? Yes, I did. Good. Double check. And what should happen now, oh, keep forgetting that it doesn't highlight the terminal just by switching tabs. If I clean my repository metadata and then do another DNF command, search for Bello again, it's going to show us it's going to re-download all that metadata, which is why I did the search before I tried to do an install. It shouldn't care yet about the GPG signature because we haven't actually installed anything. But if I try to install Bello, what it should do now is download it. It'll realize that it's signed. It'll realize it's told to check signatures. It'll realize that I've told it where the key is. And it should ask me, do you want to import this key? And this is, if I had done a -y, it should have done a yes to all here, and it would have accepted the key. But I didn't do that because I wanted to show it to you. If I hit yes, it'll import that key. It'll install Bello and Bello World. Change it to say Bello World. I don't know why you didn't do that in your RPM, Scott. This is terrible coding.
I blame
All right, and you blame who? Sorry,
Carl George.
Okay, was it his coding?
Yes.
All right, and that's the end of the demo. Were there any questions I missed as I was firing through all that?
We should use DNF --refresh instead of doing a clean all.
Okay.
Because that'll refresh the metadata files. Excellent pro tip there.
Only if I type it right.
That's right.
Uh-oh. Listed right here. Did I typo it still? DNF refresh. You must be missing something.
The only other thing, we're at the end of our time together, but I did want to make one other comment.
Sure.
Which is when we look at commonly used third-party repositories like extra packages for enterprise Linux, however, as an example, you don't do all this stuff, right? The repo manager took care of doing the GPG keys and doing the signing of the RPMs and doing the create repos to make sure that all the metadata is there. Like that's all done. What does the client do, Nate? When we're dealing
with the client. So there's a couple ways that you can install a repository. One is manually, like I just showed you, by typing in all the stuff. Obviously, you're not going to know all of that just from memory for a repository that you're getting from the internet. Sometimes those are published as just copy paste this or download this repo file. More commonly, you get an RPM that is the repository definition and the key and whatnot. And when you install that RPM, it puts the repo file in place. Sometimes it'll import the key right away, and then you can just do, DNF installs from that repository.
Yeah, and so the owner of the repository will make an RPM that is your repo definitions file, your GPG key, and then they can do, Nate said, running the GPG import. That would be part of the scripting that one could do to that RPM. And so the client side is just DNF install this. Apple uses the Apple-release RPM to provide that data. And then once you've got that installed, you've got all the repository definitions and you can go from there. So it is something you're going to use on a lot of machines, putting a little effort to making an RPM to then push across that pile of machines you want to use it may be worthwhile.
So what we used to do, again, we managed this stuff with Satellite, but we took the Apple release RPM, we put that in our local repository, which we then periodically updated as Apple had updated the repo definition. And as part of our build, if we needed Apple, we would just install that RPM along with all the base packages, and then it would be ready to go, right? Or you can clone Apple, yourself into Satellite or something, but then of course you have to manage making sure that's up to date and whatnot. And that's another way to deal with it.
Great. So Nate, any parting words of wisdom before we close out our stream today?
Sure. So I've mentioned Satellite a lot. a lot of this can be abstracted away by doing it with satellite. We didn't have time to cover repos and satellite, but I guess if there's interest, maybe we could talk about that in a future episode. Although that wouldn't quite be in the terminal, that would be in the satellite web UI. Totally different show. But just know that exists, right? That's a thing you can do that would be maybe easier if you're going to be doing these things for a larger scale of machines.
Right on. So again, don't forget to mash that like and subscribe. Join us next week as we talk about more packaging things. Although I don't know that we've really determined what the packaging thing is going to be next week. Is it going to be containers,
I think we
monkey
talked about containers next.
containers? I don't even know.
I don't know. Maybe we'll talk about satellite next. More packaging stuff up next. We don't know what yet, so just tune in. You'll find out. You'll be as surprised as we are.
And in a couple weeks, join Eric for RHEL Presents, where we'll be covering converting CentOS to RHEL on an AWS instance. So doing
Yeah,
conversions for AWS.
a quick plug. We did RHEL Presents earlier this week. If I know there's some folks I see in the chat that were also there. It was on automating RHEL image builder using Ansible automation platform, and it was pretty cool. So you should go check that out too.
All right. So for myself and Nate, happy into the terminaling, and we will see you on another episode.
Have a great one, folks.